Hi everyone, welcome to our second of four micro webinars in our microservice webinar series. Today we're going to be going over tag-based AIOps for cloud native applications. My name is Eli Kaptanopoulos. Here with me today is also Alex Mattel and John Gara. They will be handling the demo and some descriptions later on. For those of us that don't know us, RapDev is an engineering firm focused on bridging the gap between the ServiceNow platform and cloud native services. We help customers push the boundaries on ITOM and DevOps implementations, extracting value beyond standard ServiceNow use cases. Our team has a strong background in SRE and DevOps practices and brings that to the ServiceNow platform using methods like ChatOps, service-oriented CMDBs, event-based discovery, and tag-based service mapping. On the agenda for today, we're going to run through how cloud native services relate to ServiceNow, give you a demo that we've prepared, and leave some time for Q&A, and then touch on what's coming next in our upcoming webinar.
Okay, hey everyone, Alex here. So, why are we talking about this today? Obviously, everyone's heard of cloud native, and I think applications were transforming from traditional enterprise apps into cloud native apps, but we've now reached that point where most enterprises have transformed, and now they make up the majority of the enterprise critical apps. Companies did this because they realized that software differentiator is now a differentiator against their competitors. Every company is now a software company. Time to market, velocity, resilience are market differentiators against competitors. Customers expect modern, reliable services with consumer-level experiences from their apps, both in their home and their work life. And to adapt to these new requirements, application architecture had to change. Instead of large, monolithic applications like you see on the left-hand side of the slide here that had to be deployed as a single entity, run on a few large servers, have traditional long waterfall-based release cycles with many hard-linked components and dependencies. Applications are now broken out into their individual components or microservices that can be worked on independently and distributed across smaller servers, quickly deployed, redeployed, and scaled using cloud-native automation tools like infrastructure as code and configuration management, without requiring the rest of the application to be affected. Next slide, please. So this allows for developers to work on their pieces of the application that they're responsible for in parallel and release in an agile fashion. Updating individual components is necessary without having to wait for the rest of the release cycle to catch up. Dependencies and regression testing can be handled by the development team responsible for each component and delivered in a rapid, automated way using CI/CD pipelines, and use cloud-native deployment strategies such as blue-green, canary, or feature toggles to test and rapidly iterate on these features. So the aim here is to improve overall time to market of features, resilience of the service, and this is all for the benefit of the end consumer because we talked about it being a differentiator against competitors. So what's the challenge with cloud-native apps in ServiceNow? Yeah, next slide, please, sorry. Yeah, so traditional ServiceNow discovery and service mapping, they've been around for a while. They were very much focused on traditional enterprise apps, and they can't keep pace in their current form with the rate of change of cloud native microservice applications. However, ServiceNow is still the system of action and the source of truth for most enterprises. It's where we have information about who manages business services, what services we offer our people and our processes. So in our demo today, we're going to show how cloud native apps can still leverage this data in ServiceNow to take advantage of existing ITOM and ITSM processes. Recorded. To reduce the MTTR and adapt how events for cloud native apps can be quickly correlated to the microservice, and alerts can be quickly assigned to the team that supports the individual microservices. Want to go to the next one? And I'm covering this quick because I want to leave lots of time for the demo. So in our demo today, we're going to cover how developers themselves can create tag-based application service in ServiceNow as part of the development process rather than something they need to do in ServiceNow by defining metadata in a now.yaml file, which is something we at RapDev have created, and storing it with the microservice in the Git repo without the requirement for the application CIs to be fully discovered or mapped. And we're going to then expand on this to show how the new tag-based alert clustering in San Diego can be used to quickly correlate multiple alerts together into a group when more than one microservice is affected. reducing the noise, allowing for faster issue detection and identification. And then finally, at the end of the demo, we'll show how AIOps can trigger an automated remediation flow to quickly, for the remediated service based on the context in the alert, for a quick automated recovery of the cloud native application without requiring an actual human to be assigned to this task. Okay, Eli, we can move on to the demo.
Great, I will hand it over to John. I'll share your screen first.
Great. Hey, go ahead and hear this. All right. Hey, everyone. My name is John. I'm going to be walking you through the demo that we have set up today. So currently, what you can see on my screen is the operator workspace, and that's where the majority of this demo is going to be taking place. For the purposes of this demo, we have one tag-based application service that we are going to be monitoring, and then that we're going to fake a failure on and simulate that, and also some automated remediation. So I'm just going to go into this application service really quick. So you can see, again, it is a tag-based application service. The main thing that I want to point out here is these application services have a unique service ID. And as Alex was alluding to, the way that this tag-based application service was created was actually externally from ServiceNow, based off of input from developers. It came from a now.yaml file that lived inside of a code repository. Right now, I'm showing you GitHub. So one of the things that RapDev has built is a now.yaml solution that will take, declarative services and automatically map them and create the appropriate, microservices and application services, in accordance to the CSDM inside of ServiceNow. So this allows, these types of records and information being put into the ServiceNow CMDB, but without developers having to leave their tool set. Because developers don't want to log into ServiceNow, but this information needs to get into ServiceNow. So this presents a happy medium for this to take place. So for these services, you can see here that a developer actually went ahead and specified their own GUID for a service ID. Again, that we now have populated over here in the tag-based application service. This same service ID will go ahead and be tagged on all of the infrastructure. So, all of the different VMs, containers, et cetera, that make up this different application service. So what Alex is going to be doing in the back end right now is going to be mimicking bringing down the containers for this service. And you actually probably just saw on my screen right over here, this service went ahead and went red. So we already went ahead and ingested some of the events here and went ahead and created alerts for that. So I'm going to go ahead and go over here. And you can see that there is now an alert. Right now, you can see there is one alert here. Give this a couple minutes, and there's actually going to be some other alerts that come in. Just because we have one alert on the main Docker host, and we'll also have a lot of other alerts happening for the individual containers that also went down. But while that is happening, so the way that this alert was went ahead and got created is we made an event rule that went ahead and stripped out the tag that we expected inside of the event. So based off of all the different tag standards that we have in place, as I said before, we were expecting that all of the underlying infrastructure has this service ID tag. So inside of the event rule, we're able to do some regex on the additional info that was passed in, and going ahead and strip that out, look for the service ID, and do a CI field matching in order to bind appropriately to this tag-based application service. So the reason why this is really important is, in traditional service mapping and event management, you would actually be binding on the underlying infrastructure. Here with containers, it's a lot more ephemeral workloads. The likelihood that these type of CIs are not living inside of ServiceNow is high. So we don't want to be reliant on that information actually being inside of the TeamDB. And that's where this service ID comes into play. We're able to correlate and bind that directly to the service itself. So I'm just going to, yeah, here we go. This just refreshed for me. So just go ahead and I'm just going to close this out and reload this. So you can see now that there are 4 different alerts inside of this group. And this is where the tag-based alert clustering goes ahead and comes into play. So I'm just going to go down a little bit. So over here in this additional information, we can see there's a couple of different sets of tags that were found based off of the alert that came in here. So through the tag-based alert clustering, what we have here is, basically combining all these alerts into, one group so that we don't have alerts, for each individual occurrence that is really related to the overall thing. So in our example, the Docker host went down, which was an alert. There's also several different containers relying on that Docker host, which in turn had their own alerts. And we don't want to be taking on action on each individual one of those because they're all related to each other. So the way that ServiceNow allows us to do this, and again, is this tag-based alert clustering. So what we're able to do is set up these tag-based alert clustering tags and definitions such that, if the system recognizes that there's multiple alerts with the same set of keys, it will actually group them together and they will be processed the same. So the one that you are looking at on my screen right now is the one where you see the additional info key is the SN service ID tag. And there's a couple different ways that we can actually match this. The one that you can see I have selected right now is an exact match. It has to be an identical. But there's other ways that you can match it as well, such as the fuzzy and pattern, where it can be a similar based off of a certain threshold value, so that you have greater degree of control where there may be a little bit of variability. But in our use case where they're going to be a very specific GUID service ID, we want it to be an exact match. So I'm just going to go back over to this alert over here. So as you can actually see, as I've been talking, what we had set up for this alert is an alert remediation, an alert management rule to automatically kick off remediation when we saw that this system went down. And over here in the work notes, you can actually see there was a Docker auto remediation, and we restarted the containers on the host that it went ahead and got replied. So I'm just going to show you what exactly happened over there. So we can see this one right over here. You can see it actually kicked off 4 minutes ago. I'm just going to expand this so you can actually see what happened. So what happens here is, we created an alert management rule where we're going to be, matching on the type of alert that we're expecting, where we can see containers going down, and where it's one of these grouped alerts, again, so that we process the top level. We're not going to be processing, all the different secondary alerts, again, because they all come from the same root cause. So this is an automatic remediation, which means as soon as the system finds that this is the case, it will go ahead and kick off this flow. There's no manual intermediate remediation needed from the NOC or anyone like that in your ops team. So what we did here is we just went ahead and ran an SSH script and to actually go ahead and start these containers, as you can see on my screen right here. So if I go back to agent workspace, you actually can see as part of that flow, we go ahead and log a work note here. On this one, it successfully restarted. There's, depending on the use case here, we can log work notes, for some reason, maybe it wasn't able to restart, we can have that here. And then there actually could be an actual manual remediation needed to be, right, because of this, it was auto, no one needed to be notified of it. But since we have the service definition details, we know the owner, we know groups, we also have the flexibility there where if this auto remediation fails, we can go ahead and notify someone to say, hey, you need to go ahead and take a closer look at this, you need to figure out what was going on. The automatic remediation failed. And if I go up here in the history, you can see that the alert group was closed. And if I actually go back to the overall workspace here, it actually, you can see it just refreshed. It went back to green. So again, in this demo, this was green. We simulated an outage. It went red. It took less than 5 minutes for the system to actually recognize that that was the case. An automatic remediation flow kicked off to restore this. It was successful. We got the all clear coming into ServiceNow, and the system is now green again.
Awesome. Thank you, John. And now we are going to turn it over to Q&A.
So we've got one question in the chat from Michael Hart. Is there a process diagram that tells us the actions that have occurred in the auto remediation, including decision trees? We don't have that in the deck, but we can certainly put one together for you afterwards if you're interested in that. The basic flows, as John described. So we have the monitoring. We use Docker labels for tags. Those are ingested into Datadog. And then we're using monitors in Datadog to provide the alert into ServiceNow and using the additional info metadata and the tag clustering to do the correlation and grouping. But yeah, we can get back to you with a process diagram after the webinar. Any other questions? We've got a question in the chat. What was the underlying monitoring solution interacting with the Docker container in ServiceNow? It was Datadog. So we have the Datadog Docker container agent installed, monitoring the containers. It's automatically taking the container labels and converting those into tags. And those then get, one of which is the service ID that was defined by the developer. So the idea here is that the same developer that obviously deployed the containers and created the application service in ServiceNow using the now.yaml in their repo uses the same service ID. And that way we were able to correlate the containers from Docker, any AWS images that have the same tag. You could use them in your EKS pods, etc. And then to tie that through to the application service that was created using the now.yaml. Hopefully that answered the question.
And we do have another question. So did the correlation occur inside of ServiceNow? So yes, it did. So in terms of generating the alert, that came from the event rule, and inside of event rules, it's basically just different conditions where, you're going to be looking at different attributes and different binding that occurs. So that is where we, as part of the monitoring solution, Datadog sends information into ServiceNow about the event that happened. As part of that payload, there is the service ID tag. When we also see different information about this event, we set up certain conditions so that this event rule fires. So that will go ahead and create the alert and also bind to the tag-based application service CI. Now, in terms of the correlation amongst, that group that happened, where we had a group alert where there was a primary alert and then there was secondary alerts underneath it. That correlation also occurred inside of ServiceNow. And the way that was done was through that tag-based alert clustering solution that was introduced inside of San Diego. And that one was, if you remember where I showed my screen, where there was different options to have an identical match, a fuzzy match, or a pattern-based match. That is where that sort of configuration is that is set up, where we specified the SN service ID key, where if the system recognizes any sort of alerts that are open that has this same set of a key and there's a corresponding matching value, that those will be go ahead and grouped together and correlated.
And do we have any other questions? You could always follow up after via email, and we'll have that at the end.
Yeah, so we do have another question inside of the chat here. So is there a flow to problem management for this incident, and would it just tag the service? Would you be able to track or see a history of recurring issues for this container or service? So that is a good question. So for the purposes of this demo, since it was an automatic remediation, we did not go ahead and create an incident for it just because it didn't have to have manual intervention. Now, obviously, depending on the use case, we could also have created the incident and auto close that incident out as well. It really just comes down to your organization's use case of when incidents should be created in terms of tracking. And then that could also lead into problem management, as you were saying there. And yes, all of this information is available for tracking, for reporting and metrics. So the alert is tied to the CI. And if we were creating that incident would also get that CI applied so that you could do an overall reporting on that to see, how often this service is going up and down. Good question.
We've got a question from Paul in the chat. I missed what detected the outage. Was it a K8 detected synthetic transaction? We were actually just using the Datadog container monitoring solution for this demo, but you absolutely could detect it it could be from any event. So if you were using Kubernetes, you could subscribe to the event queue and get the notification that way. But for our demo, we used the Datadog Docker agent to monitor the containers.
Awesome. Thank you guys all for joining. I hope you enjoyed today's demo. We are scheduled to have our next webinar on June 23rd, where we will be digging deeper into the now.yaml solution for declarative services in your CMDB that John highlighted at the beginning in GitHub, and show you how that works. And if you do come up with any other questions from now until the next webinar, you could always reach out to us at the email below, now@rapdev.io. Thank you very much.